Alright, for today's tutorial, we will show you how to use LabVIEW Sweep and Go. Sweep and Go can turn a 3-hour lab into a 30-minute lab if done correctly. The reason why time is cut down is because it gets rid of the manual labor such as changing the outputs of a power supply and measuring the current each and every time you change it. First of all, you will need to go onto this link that you see right now, which will lead you onto Dr. Braun's website. Once you access Dr. Braun's website, you can scroll down to download the Sweep and Go library file. Download and open up this file. Alright, once we downloaded and opened up this file, when you open up the Sweep and Go file, you would notice the library manager, LB manager as seen on top. And what you want to do is open the main.vi file, which will open up Sweep and Go. In the Sweep and Go screen as shown here, you are able to set the devices in labs through the computer as opposed to doing it manually. And you can also collect data.
So today we're going to be working on experiment 7 part 1, the NPN BJT pinout and junction breakdown measurements. First thing you need to do is you need to turn on all the instruments in front of you, all the 7 instruments. If one of them is not on, then none of this is going to work at all. Now let's move on to step 1. Now you see the 3 instruments at the top, these are always going to be turned or used remotely by Sweep and Go. These bottom 3 right here, these you can turn on and off if you choose to, if you want to use them. In this case, we're not going to be using the oscilloscope or the fluke multimeter, so we're going to leave those off. The Keithley, on the other hand, we're going to use, so we're going to switch this one on, like so. Step 2, this is going to set the sweep parameters of how your plot's going to look. In this case for the experiment, the power supply is not going to be used and the function generator is not going to be used, so we're going to leave those the way it is. The source meter, on the other hand, we're going to use this as the input voltage source, so we're going to set this to volts and set the source meter to start at 0, to end at 16 volt, and to step 1 volt every single time. The loop selector here we're not going to talk about because it is not needed for this part of the experiment, but it will later be explained more thoroughly with another video. Step 3, we're gonna leave the function generator as high Z because we're not gonna touch it. Same with the power supply, we're gonna leave that at 8 volts because we're not gonna touch that either, since we're not using either of them. The power supply current limit we're gonna leave the way it is. The source meter current limit though, we're gonna set it as 20 microamps as per said by the experiment. The sample noise count, we can set that to 1, and then these bottom 2 options right here we'll just leave at DC voltage because we're not going to use them. Now last step is to collect data. First things first, you need to know is that the x-axis is going to be the source meter, the voltage input, so we're going to have that set to the source meter. The y-axis is going to be the current that we measure from the source input, so that's going to be the source meter measured in amperage. After that, you're going to press this arrow right here, run it, name it test.1 or whatever you want, and go. And just watch as your plot gets plotted. Alright, now it's done. Because it stopped this early, we can tell because the red arrow is gone. What we're going to do now is we're going to minimize everything and open up the file you just made. And here you see all the data that you collected just now in awesome looking columns. What we're really interested in right now is the source meter right here in voltage. So this is basically the input voltage source and the current that we're measuring or we want to measure. We're going to tabulate that right now. So what we're going to do right now is going to graph it as a line graph. Oops. There we go. And basically, this is what your graph is going to look like.